Alright, I'm Jackson Custer and I'm doing question 8. So the question is, sulfur hexafluoride is a very stable gas, useful in electrical generators and switches. It is formed by direct synthesis from the elements. S plus F2 is equal to SF6. And this is not balanced. So if the question is, if 92 grams of SF6 is produced from the reaction of 115 grams of sulfur and 110 grams of fluorine gas, what is the percent yield? So the first thing you want to do is balance this equation. And so you have one sulfur over here and one sulfur over here. So you're good right there. But right here you have two fluorides and 6 fluorides right here. So what you want to do is you want to add a 3, so that makes it balanced. So it'll be 3 times 2, 6 is equal to 6. So once you got that, you're gonna use the percent yield formula, which is the actual yield over the theoretical yield times 100 will give you the percent yield. So what you're gonna do is, to start off, you're gonna go 115 grams of sulfur. And right now you're gonna try to find your moles of sulfur. So you're gonna use the molar mass, so 32.06 grams of sulfur is 1 mole of sulfur. So you're gonna calculate that. And then I like to keep going with the equation so that I can find the excess and limiting reagents. So I'm gonna keep on with the equation. So I'm gonna go 1 mole is equal, 1 mole of sulfur is equal to 1 mole of SF6. So this is the molar ratio. So it's 1 mole of sulfur is equal to 1 mole of SF6. We're using the coefficient in the front. So once I get that, I'm going to extend this more. And I'm going to go 1 mole of SF6, and I'm going to use the molar mass of SF6. So it'll be 146.06 grams of sulfur 6. And so you're going to calculate this whole thing. So you're going to enter all this into your calculator. Give you some time to do that. Alright, so what you should get is 523.92 grams of SF6. So this number is how many grams of SF6 you get from this number, 115 grams of sulfur. So next you're going to find this again, but for fluoride. So you're going to go what it gives you, so 110 grams of F2 for the fluorine. And so fluorine, the molar mass is 38 grams. Which is 1 mole of F2. So once you get this, you're going to use the molar mass to find the moles of, or to find the grams of the SF6. So you're going to go, for every 1 mole of SF6, there are 3 moles of F2 because of the equation. Use the coefficient. So it'll look like this. All right. right, so once you add that, then you're gonna put in the grams of SF6. And then you're going to calculate this out. I'm just throwing this all in your calculator. All right, so once you get that, it should be 140.94 grams of SF6. All right. So this is your limiting reagent because it is a smaller number than this right here. So this is your excess, this is your limiting. So then you're going to use your limiting and plug it into the equation. So your limiting is also your theoretical. So you go 92, because it gave us the 92 grams of SF6 is produced. So you go 92 grams SF6 over 140.94 grams SF6. So you calculate that, and you should get 0.653. So now you have to multiply it by this should be 140. Okay, and then you multiply it by 100, so you can get the percent yield. So it'd be times. That is equal to 65.3%. All right, and that's how you get the percent yield of this problem.